I want to do a quick video on functional programming, and I thought I'd kind of build it up in a way I haven't seen done before, where we take some basic logic, we start expanding it, and then we see how we could abstract parts of the logic to make it more functional. So I'm starting out with underscore.js and 3 different functions that do operations on 2 arguments. And then over here I have nodemon running with this file so that anytime we save it, we'll see the results output over in the console to the left. So one day we figure out this app's going to need to be able to handle more arguments in these functions, and maybe a lot more functions that I don't have here. So one way you could make the add function handle more arguments is to use one of underscore's functions called reduce. And what it would do is take the arguments and return, operate on them with a function pretty similar to what add was already doing. I'll just copy it in here. And now add will be able to handle as many arguments as you give it. Let's do a quick example with console log. And we'll add just a few numbers, save that, and then look over at the console. You can see that the answer is 24. Okay, so that worked fine. Why not do that? But we also need to expand multiply and divide. So one thing you could do is copy the logic, except for the operation, into each of these and every other function that was going to use it. But there's a more functional way. In functional programming, we abstract that kind of logic into a function, and then you pass the function around to save a lot of typing. And if this logic ever changes, you only have to change it in one place instead of changing it throughout your application. So how would we do that? Let's get rid of the extra logic I added here. And here we have the basic add function. Now we know we want to be able to add a reduce to each of these, so we're going to make a function and we'll call it reducer. You can call it whatever you want. But what it's going to do is it's going to have that reduce logic inside of it, and then all the other functions can use it. So just like we did with the add, it's going to return underscore.reduce, and reduce took a list of arguments like the numbers 10, 4, 7, and so forth. That came first, and then it took a function. The first thing we've got to do here before we write in those arguments is figure out how we want to call it. And the way I want to call it is pass in a function, for instance add, and then pass in some the numbers to add or operate on. So something like this should work. Now, as you see, the first argument we're passing in is the function, and reduce calls the function second. So we're going to switch it around a little bit to make that work. And we're going to call underscore.first to get the first argument, and underscore.rest to get the rest of the arguments, which goes second. But there's a little gotcha there. This won't be a true array because arguments, it's an object and not an array. But one way to flatten it down to an array is use underscore.flatten. So we're going to flatten the rest of the arguments to pass into reduce first, and then we're going to take the first argument as the function, which gets passed into reduce second. Now for calling it. We already wrote out how we want to do that, but let's make a little function called do something, and it's going to be the one to call reducer. But it's not going to call it with some hard-coded array. It's going to pass in the arguments that it receives, and it's going to use a function that's hard-coded into it. Otherwise, if you passed in the function as well, you might as well just call reducer without using do something. So that'll make more sense in a second. Let's make a way to show the output. We're going to say do something with some arguments. Gives us that result, and then log the result out. So you see the result for this using add and these arguments is 21. Let's add 8 and 9 to it, and we get 38. And what if do something was called with divide? It's a pretty small number, but you see it's working. Multiply. There you go. So we've abstracted this logic, and now we can use it with any of our functions that take 2 arguments and operate on them. For instance, we could make a function called adder. And that would always be the one that does the adding. You could have a function called multiplier. And that one would be the one that does the multiplying. You can see our answers are changing just fine. And if adder is the only thing that uses add, you can input the logic directly, like this, and it's still going to work, as you can see. So this is kind of the functional way to abstract out some logic like reduction and use it anywhere without rewriting the logic. It's a lot easier to just return the reducer of these arguments than it is to constantly write underscore reduce flatten rest and so on and so forth. Also, if you want to one day change the way all these functions work, the way they reduce, you can only change it in one place, and it's going to affect all the other functions. And that's the power of functional programming. We're abstracting all this logic that can be reused and never writing it twice. So I hope that was helpful and gave you some ideas in your own applications.